As you build bigger and bigger Vue applications, managing your application state, your application data, can become more and more challenging. This module is about a better state management solution called vuex, which can be used to replace provide and inject for data which you want to share across multiple components, possibly across your entire app. Now, to understand vuex in detail, in this module, we'll first of all dive into what exactly vuex is and why exactly we need or use it. And then, of course, we'll explore it from the ground up so that you understand how vuex works and how you can use it in your Vue applications to manage your application data in a better way. So what exactly is vuex? Vuex is a library for managing global state. Okay, that's a nice sentence. What does it mean? What's state? State could simply be translated with data. Data your application needs and data that affects what the user sees on the screen. So you can think of state as reactive data, data which may change and where such changes then should trigger something on the screen. And Vue.js is all about this reactivity, of course, as you learn throughout the course. But managing data, state, that affects different components of your app can be tricky. For that, it's important, though, to differentiate between two main kinds of state: local state and global state. Local state is the state, the data you manage inside of one component, which only affects this one component and possibly indirectly through props, also a child component. Here, examples could be user input that was entered into input elements, or for example, a button that shows or hides some container. And I got an example for you. This is a course project we built a little bit earlier in the course, after the main component sections. It's this learning resource manager. And in there, in the add resource.vue file, in the add resource component, we, for example, have a form where we fetch user input. And that user input, as well as the overall form validity, only matters to this component. Here, for example, we have this input is invalid data, and therefore that would be the state of that component, which influences whether or not we show this dialog. So this input is invalid data piece is state because it affects what the user sees on the screen. We show or don't show this dialog, and it really only matters to this component. We manage it internally in this component, so that would be an example for a local state. On the other hand, global state is state, data, that affects multiple components, possibly the entire app. So data which you need in a lot of different places. Examples here could be the user authentication status, whether a user is logged in or not, shopping cart items which might be presented in different parts of the app, and similar examples. Again, in this app I just showed you, an example for global state could be found in the resources view file. In there, I got these stored resources, and those stored resources are changed through the add resource method, for example, but this method is triggered from inside another component, and the stored resources are also used in other components of this app. So this is an app-wide, or at least a multi-component state. It's data that's used across multiple components. And it's the global state where vuex can help us. Because thus far, for example, in this app I just showed you, we managed this state through provide and inject. And this works, and this is not necessarily bad, but it has a couple of drawbacks which might or might not matter to you. One potential disadvantage, for example, is that you end up with all the data and all the methods to change the data in one component. In this case, the resources component, which therefore gets rather big and which has a lot of data and a lot of methods inside of it, which isn't really needed for the template of that component, but which is simply needed in other components. So getting such a big component which manages cross-component state, that can be hard to maintain as your application grows and as you maybe have more and more global state to manage. In addition, provide and inject can have some tricky problems regarding reactivity. It depends on which data you provide and inject. And whilst there are solutions for all possible problems you could face, a solution like vuex in the end might be the best solution. Now, why exactly is vuex a good solution though? Why might it be worth a look? As I just outlined, managing app-wide or global state can be difficult. You end up with such fat components which have a lot of logic in them which isn't needed for the component template, but in other components of the app. You also might have unpredictable behavior in your application because it's not always immediately obvious where state gets changed, or maybe it's possible to change state in ways that you don't want it to be changed. It also could be error prone because accidental or missed state updates could happen. Coming back to this example, in the component where we inject the resources, we get the resources array, which we also manage in the resources.view. Now, theoretically, we could edit this array in the place where it is injected, and we would be editing the exact same array in memory. We're not doing this here, but you could do it accidentally, or maybe because a colleague is working on the code who isn't paying close attention. And that is exactly what I mean with it being unpredictable or error prone. You can edit data in places where it shouldn't really be edited. Of course, if you're working on your own, this might not be a problem, but in bigger projects and in bigger teams, it could become a problem. And that's exactly where vuex helps us, because with vuex, we outsource the state management. It's no longer in such fat components. Instead, it's in a separate place, detached from the components. It's also more predictable because vuex has some clear rules on where state should be managed and how it should be updated and shared. And therefore it's also less error prone because we have that clearly defined data flow, which we have to adhere. So that's the what and why. Now let's install vuex and let's get started using it. Now for this module, as many times before, you find a starting project attached, which you can download, extract, run npm install, and thereafter you can run npm run serve. Though before you run npm run serve, let's already install vuex. And you can do this with npm install --save vuex. This now installs the vuex package into the project, just like we installed the router earlier in this course, and now we can get started using vuex. And for that I got a very simple application here. Definitely not an application where we would need vuex, but a great application to understand the core concepts vuex introduces. So let's start the development server with npm run serve, and let's see what we got on the screen. We got this simple container here where I just say vuex. Now to get started with vuex, let's say here inside of this base container in the app view template here, I want to have a button where I say add one. And above the button, I actually want to have a counter. Let's say a h3 tag where I output the current value starting at 0 and then incremented by 1 every time the button is pressed. Now we could, of course, implement this behavior just with data and methods and what you learned. And for a simple app like this, we normally would do that. But this module is about vuex and understanding vuex, so let's not do it with these tools. Instead, let's manage this counter state with vuex as if it would be some global state which we need in other parts of the app as well. And for that, we start in main.js, and we start by creating a vuex store, which stores our application state. And there is one store per app. So we create the store by importing from vuex, and what we import is the create store function. And you might see a pattern here: create app for the main Vue app, create router for the router, create store for the store. Then we can store the store in a constant named store, and these are a lot of stores, I guess, or storages. And we can do so by calling create store. Now, create store takes an object where we configure the store. And the most important thing with which we start in our store is the state. State is a method, and it then should return your state object. So it's a bit like data in a component. Now, this is the state of your application. So this object will hold the application-wide data. And you only have one store for the entire application. You might have multiple states though, but I'll come back to that later. Now, to get started with our counter here, we could have a counter here in our state object and initialize it to a value of 0. Now we need to connect our app to this store, which we do by calling app use and passing the store to it, just as we used the router in the routing module. And now we can use that state in our component, in any component of this entire app. We don't need to add inject here or anything like that. We can just use this state. And how do we do that? Well, there now is a new property which we can access in every component. And that's the $store property, which points at the vuex store. This then has a state property, which points at the state managed by the store. And that state, of course, is this state object. Therefore, we now have a counter property in there to access our counter. And if I do that and save this, we see 0 here. Now, clicking the button, of course, doesn't do anything yet because we haven't wired this up. Let's do this next. To wire up the button, we can add a method here. Add1 could be the method name. And it's the method I want to trigger upon a click on this button, just as we learned it before in this course. Now in here, we can access this $store, access the state and there the counter, and increment it like this. We can, by the way, also outsource this here into a computed property if we want to. We can add a computed property, name it counter or whatever you want. Doesn't have to be counter. And in there, return this $store state counter. And now we can use this counter here, save everything. And if we now go back, we can click add1, and this now updates with help of vuex. Now, vuex has way more to offer than just that, but this already shows us how it works in a nutshell, how you work with vuex state in a nutshell. And the great thing is that you now can really add any component you want, like the counter.view. And in there, we can add this h3 tag. So let's add it in the template of the counter. And in there, I then add this computed property. So this computed property that calculates the counter, cut it from app view and add it in the counter view. And if we now register the counter here in app view, like this and like this, we can add it here above the button, just like that. Save everything. And it will still work as before. If I reload, this still works because it's really a global store, a global state that can be accessed from any component without injection, without passing props around. Now, this doesn't replace props in general. To a direct child, you typically want to pass props if you, the parent component, have the data. But for application-wide state, like here for our counter, vuex is great because without any extra setup, we can tap into the state and use it. Remember this slide? There I mentioned this predictable state management, this predictable flow, the clearly defined data flow, which makes sure that we have to use a certain approach of updating our data and of getting our data, and this would be less error prone. Well, actually, the way we're using vuex at the moment works, but it's not fully following the vuex philosophy. We're directly tapping into our store state to change something from inside a component. And whilst this works technically here, this is not ideal. We can change the state from anywhere in the application, and it's up to us if we add 1 or if we set it equal to state counter plus 10, or we have a typo and accidentally type 1 twice and hence add 11 every time we increment this. So what I want to say is that here we still can introduce errors because we're not having a clearly defined state changing mechanism. We can change the state from anywhere. That is why we should use vuex a bit differently. We have this app-wide central data store, this state store, and we communicate with it from inside our components. Now I have a dashed arrow here because yes, we want to communicate, but not directly. What we're doing at the moment is not ideal. Instead, vuex has a built-in concept called mutations. Mutations are clearly defined methods which have the logic to update the state. And from inside our components, we should in the end just trigger those mutations instead of directly manipulating the state. By triggering mutations, all components that want to edit a state do it in the same way, and it's guaranteed that they do it in the same way. And to give you an example, I will actually add another component here, change counter.view, and this will be a very simple component which also just has a button where I also say add 1, and where upon a click I want to trigger add 1. And then I have my script in here, and in there my methods, where I have the add 1 method. And every component is able to use vuex as you learned it. So here I can access store state counter and increment this by 1. Now in app view we can import change counter and register it as a component and use it in addition to the button which we already have here. So I got 2 buttons now, one here in the app component and one in change counter. Both should add 1, but here I'm adding 11 because I mistyped or I changed my logic and forgot to rename the method and the text on the button, whatever. But now we have 2 buttons, one button adds 11 and one really adds 1. Now why am I doing this? I want to show you that now we have different places in the app where we update our state. And even if we wouldn't have that stupid mistake of having 11 here, even if we would have 1, if we ever decide that we want to add 2, we have to change that in 2 components. We have to go to 2 components and change our logic in 2 places. And in bigger applications, we might have even more places where we need to change the logic. Now that's a lot of code duplication, and that's exactly why we have this mutations concept. Back in main.js, where we create our store, we don't just have the state here, we also have mutations. Mutations takes an object, and in this object you can define methods. For example, a add 1 method, or increment, whatever you want to call it. And this method should contain the logic to change this state. Now this method will automatically get the current state as an argument. This is guaranteed by vuex. Vuex will give us the current state whenever this method is triggered. And I will show you how to trigger such a method in a second. And since we get the current state here, the guaranteed latest state, we can access state counter in here and increment this by 1. Also, of course, with this code. Or if we ever change our logic, we simply change it here. And now we want to trigger this mutation from all the places that should change our state. And of course, it should be needless to say that you can have multiple mutations. You can have as many as you need for your application. So here I got 1, and I want to trigger it for the button in app view and for the button in change counter. Now let's start with the button in change counter. Here, to trigger a mutation, we access this $store, but now there we got a commit method. It's a built-in method which vuex gives you on its store. And commit takes the name of the mutation you want to perform. In this case, that's increment, and the name should be provided as a string. It's increment because I named my mutation increment. If you used a different name here, you also need to commit a different name. But now we can commit this here in change counter and also in app view. And now we moved the logic, the concrete logic on how the state is updated out of the components into our store, into this mutation. And we just commit this mutation from inside our components. So now if we save that, this still works, but now with help of mutations, which is the more elegant and more predictable way of updating our state. Now some mutations might require arguments. Here we got the increment mutation, and the value by which we increment this is hard-coded into this code. We could add an increase mutation, which also gets the state, and say that in here we also want to change the counter, but we actually want to increase it by a value which can be defined when this mutation is committed. And to also allow for this scenario, your mutations actually also take a second argument, a payload, so a data package that can be appended. And I'm going to name the argument payload here, though of course these names are up to you ultimately. Now payload can be anything. It can be a number, it can be a string, it can be an object. And let's say here we assume it will be an object where we have a value property. But this is entirely up to you. It's your store, your application. You can expect any kind of data on committed mutations. But how could we now call this? Well, let's say in change counter, we say add to because that's more appropriate to what happens here. But in app view, I don't want to commit increment, but the new increase mutation. And I want to increase the counter by 10. Now, I still don't want to manipulate the state from inside this component. I still want to use a mutation, but I want to pass this data package to this mutation so that we have some flexibility. For that, commit takes a second argument, which will be the payload, which then later is received in your mutation. So the second argument here, indeed, is also the second argument you can pass to commit. And this can be anything, as I mentioned, a number, a string, but here it should be an object with a value property, because that is what I'm expecting here. I'm accessing .value on the payload in my mutation here. So here I provide a value, and in this case, let's say the value is a number, and it's the number 10. If we now save this and reload, add 2 adds 2, because it commits the increment mutation, but add 10 adds 10, because it calls the increase mutation with a payload that contains this value of 10. So payloads, extra data, can be passed to your mutations. You also got an alternative way of committing, by the way. There's nothing wrong with this approach, but you can also call commit and pass an object to commit. Now this object now needs to have a type property which holds the name of the mutation that should be committed. But in addition, it can hold as many properties as you want, for example here, this value property. And then it's this object, without the type so to say, which will be provided as a payload to this mutation. So that's simply an alternative way of committing, and it's up to you which approach you prefer. This will also work, as you see here. Now these are mutations, and the clear advantage is that you move the concrete logic that changes your state into your store. And here, of course, it's very simple logic, but this could be way more complex in the end. And you just commit mutations from inside your components. So you never, and that's really important, you never directly edit the state from inside components. This is not considered a good practice. You should instead use mutations. So we use mutations to edit our data in the state, in the store. Now, just as we shouldn't directly edit the state from inside components, we could also argue that directly reading the state might not be ideal. Why could this be suboptimal? Well, in this app, we got the counter component where I output the counter. Now, let's say for whatever reason, we also have another component, favorite value dot view. And in there, we do the same thing as in the counter, but maybe we do more. That's why we have a separate component. So we do more here. Now, of course, we can use this component here in app view. We can import favorite value from components favorite value.view and register this here, and also add this here below the counter, maybe favorite value like this. Now, of course, this will work. We got the counter twice now, and it updates in both components. Now, let's say we decide that actually we always want to output the counter times 2. So we update it here in favorite value, and we update it in the counter. Do you see the problem? We are again replicating logic here. We do have duplicate code. And again, in bigger, more realistic applications, this might absolutely happen, that we need the same kind of data in different components, and then we decide that we want to format or calculate the data differently, and therefore we suddenly need to change it in all the different places. This is why we might not want to directly talk to the state. Instead, we can use a concept called getters, which in the end are, you could say, computed properties defined directly in the store, which we then can use from inside any component of our choice. So here's how we add a getter to our vuex store. Next to mutations, doesn't matter where exactly, but in the same place as state and mutations, you add getters. This takes an object, and every getter is a method in this object now. So basically, just like computed properties are methods in the computed option of components. Here, we could have the final counter getter, let's say. And the final counter getter method, like all getter methods in vuex, gets 2 arguments. The current state, which we need to get a value out of it, and other getters. Getting other getters in a getter can be helpful if the value you want to calculate here depends on the result of another getter. But let's ignore that for now. Let's just work with the state argument. We want to return a value here. A getter has to return a value. And the value here is our counter, which is managed in the state, times 2, let's say. And we can now use this getter from any component of our choice. For example, from inside the counter. Here in this computed property, which we keep, we now access this $store, but no longer the state, but instead store.getters dot, and then the name of your getter, which in this case was final counter. So here it's also final counter. And you don't call it, you don't execute it, you just point at it. Like this, like a property. And vuex will execute this getter method for you then, passing in the current state into the getter. So we do this here in the counter and also in favorite value. And with that, if we ever decide that the counter should be, let's say, the value times 3, we just need to do this in one place instead of in two places. So with that, if we go back, you see this works now. And this is the concept of getters. Now, I mentioned that you can have multiple getters and that getters can also depend on each other. Let's say, besides our final counter getter, we have another getter, which is called normalized counter. And the idea here is simple. I want to use my counter value, to be precise, the final counter value, but I want to make sure it's greater than 0 and smaller than 100. And I either output 0 or 100 if one of these boundaries is crossed. Now, one way of building this would be that we recalculate our counter times 3 here, and then we have our final counter here. We check if final counter is smaller than 0, which can't happen here, but let's say we still check it, in which case we return 0. We check if final counter is greater than 100, in which case we return 100. And only if neither of the two things is the case, we return the final counter. As a side note, this also shows us that you, of course, can have more than one line of code in a getter. That's another advantage of using getters. You can move such code out of components into your vuex store so that your components stay lean. But now with that, we got the normalized counter, and we could use the normalized counter in the favorite value component, simply by referring to normalized counter here. That is the name of this getter. And with that, you will see that as soon as we exceed 100, the bottom counter stays at 100 because of the logic we just added. Now this works, but it's not great. We are calculating something which we already calculate in another getter. And that's why we get this getter's second argument here. With that, we can refer to our getters and get our final counter simply by calling getters.finalCounter. And imagine we had more code in there. Replicating that all in another getter is just unnecessary if we already do have a getter for that. So that's why we can use final counter like this here. And in this case, I don't even need the state then, but if we would need it, we could still use it as well in this second getter. Here I will replace the state argument with an underscore, which is a convention signaling my setup, my project setup here, that I do have to take this argument in order to get to the second one, but that I don't want to work with it. Otherwise, this specific project setup would complain about an unused argument. Following this naming convention, it won't complain. And with that, if we reload, we got the same behavior as before, but now in a slightly more elegant way. Now we got mutations and getters. What could be missing? There is another important concept, another important feature vuex exposes. But in order to understand it, let's go back to our code. Let's say in the increment mutation, we don't want to increment immediately. Instead, we want to wait 2 seconds and then increment. Now, this might be a dumb example, but a better example could be an app where you send an HTTP request and you wait for the response, and only once the response is there, you want to change your state. Put in other words, you sometimes have code which runs asynchronously, which doesn't finish immediately, but sometimes in the future. The problem is that mutations must be synchronous. You're not allowed to have any asynchronous code in there. So if you run a mutation, It needs to execute step by step by step without any pause and immediately change the state. It's not allowed to do anything that may take a bit longer. The reason for that simply is that if multiple mutations execute, every mutation should get the latest state. And if another mutation was committed but didn't finish yet, that is unexpected and will lead to errors in your program. That's why a key requirement of mutations is that they have to be synchronous. But what if I do want to wait for 2 seconds? We could do this with set timeout. There we could wait 2 seconds, and in the function here, which then executes after 2 seconds, we update our state. But this is actually not allowed. It will work if you try it, but it is a very bad practice and nothing you should do. Instead, vuex has a better concept in place for working with asynchronous code. Besides mutations and getters, it also has actions. And components should trigger actions, which then in turn commit mutations. Because actions can now use asynchronous code. And because of that, it's actually considered a good practice in general to always put actions between components and mutations, even though components could commit mutations themselves, and that wouldn't be a problem if you only had synchronous code. But even with that fact, that directly committing mutations from inside components often would not be a problem, even with that, it is considered a good practice to always put actions in between to ensure that you never accidentally put asynchronous code into mutations. So how do actions work then? How do we add them to our store? In main.js, besides mutations and getters and state, we can add actions. And I'm doing this here. I'll add actions here. And actions also takes an object, just like getters and mutations did. An action, again, is just a method. For example, increment. You can use the same name here as you do in your mutations. So here I got an increment mutation. I'm also using an increment action. You don't have to use the same name, but often you will, because often you just have an action in between a component and a mutation. So using the same name makes sense. Now this action will get an object as an argument, a context object. And this context object is full of interesting things. The action will get this argument automatically by vuex, like all these vuex features do. Now context, for example, has a commit method, which you can call. And it does what you think. It commits a mutation, just like you could commit it from inside a component. You can pass a second argument as a payload, and you can pass an object alternatively to the 2-argument way of using it. But here I only need 1 argument, and that will be the name of the mutation that should be committed. Now we'll have a look at the other things inside of context in a second, but for the moment let's leave it like this. And now we got an action which commits increment. The interesting thing is that actions, unlike mutations, are allowed to run asynchronous code. So we can take our timeout here and wrap context commit with it. With that, the mutation is synchronous again, but the action is asynchronous, which is allowed by vuex. It simply commits the mutation only once the 2 seconds have passed. And now we need to change our component code and make sure that we don't commit from inside the component, but that we use the action instead. And how do we use an action then? How is that meant to happen in vuex? Well, inside of the component, where we previously committed, we can now dispatch an action. And the cool thing is, the syntax for dispatching is pretty much the same as for committing. You can either dispatch with 2 arguments, where the first argument is the action name, so in my case, increment here, and the second argument is a potential payload you want, or you use the 1-argument syntax. Here, however, I'm dispatching increase, which doesn't exist as an action yet, so I will quickly also add an increase action so that this will work. Simply add a new action named increase and context commit increase here. Your action will receive the payload that was added to the dispatch function, like value here or like this second object, as an extra argument. So here we will automatically get payload, which we then can forward to the committed mutation. So this is how we can set up an action that also has a payload and forwards that payload to the mutation. Of course, you could also change the payload before you commit this mutation. You can do whatever you want to do in this action, whatever needs to be done for your application to work correctly. But let's get back to the components. We dispatch actions just as we committed mutations, with the difference that we now run actions instead of mutations. And therefore, we can also do this in change counter and simply dispatch the increment action here. And with all those changes in place, if we go back, this still works, and only after 2 seconds the add to button click is having an effect. But now we're doing this in the proper way using actions. So actions are important for asynchronous code, and in general, it is a good practice to use actions. Now, I did mention that we have this context object, which we get as an argument automatically, and that it's full of interesting things. Thus far, we're only using the commit method though. So what's inside of context as well? Well, we can simply console log context to have a look into it. So now I log it in increase. So if I run add 10, here is the log. And we see we got this commit method, which we already saw, but we see a couple of other interesting things. Let's ignore root getters and root state for now, but let's have a look at dispatch. You can also dispatch another action from inside an action. This can be helpful if you're sending an HTTP request, and if it succeeds, you want to trigger a success action. If you get an error, you want to trigger an error handling action. Then you could have one action that dispatches multiple other actions in reaction to different results of a HTTP request. You can also access getters in case your action needs some calculated value which you derive in some getter. And you can also directly tap into the state in case getting access to the getters might not be enough. You should not manipulate the state from inside the action though. Always use a mutation for that. So that's context, and these are actions. And with state, mutations, actions, and getters, we got the core concepts vuex uses to manage state application-wide, which you can then use conveniently from inside any component. Now we know the core vuex features. We'll see it in a more realistic app in a second. Before we go there though, let's talk about a couple of utility features, which make our life as a developer a bit easier. And let's start with mappers. In the counter, for example, we have this counter computed property where we in the end just access our final counter getter. So we have this code here just to get access to our getter. Now this is obviously not a lot of code, but we're not doing anything besides drilling into our store. This is not horrible, but in case you're not happy with that, vuex has a helper which you can use. You can import something from vuex, and that something is a map getters function. You can use it inside of this computed object. Instead of defining a computed property on your own, you can call map getters here, and this will return an object which you can then spread with the free.spread operator into your computed property object. So map getters gives you an object which we now merge into the computed properties object. Because the object map getters will give you is an object full of computed properties which are defined automatically for you. Well, now which computed properties do we get here? Well, map getters takes an array as an argument, and in here you list all the getter names as strings which you want to have as computed properties in this component. So in this case, for example, the final counter, but of course we could have multiple getters here. And now this will give us a final counter computed property in this component, which automatically points at the final counter getter. And with that, we just need to change this here to final counter, because that will be the computed property name. And then if we reload, it still works as before. But now with map getters, especially when you use multiple getters in a given component, you might be able to save some code and not drill unnecessarily into the store all the time. Now we have something similar for state and mutations, but you don't really use those in your components anyways. So let's have a look at map actions then, which also exists to map actions into your components. How does this look like? Let's say in change counter, we don't manually want to define methods, which in the end also just drill into the store to dispatch some action there. Instead, we could, just as with getters, import something from vuex, and that something here is map actions. Now, just as with map getters, we call map actions now inside of methods though, not inside of computed, but inside of methods. We call map actions like this, and again get back an object which we merge with the methods object by using the spread operator. Map actions now also takes an array, and now here we define all the action names which we want to have as methods in this component. So in this case, increment. But of course, we could also add the increase action here to map both actions to methods in this component. And these methods will be created for you by map actions. That's the idea behind using it. Now with that, we could add a second button. And on the first button, call increment. That's the name of the method which will be created for the increment action. And point at increase on the second button. Now, of course, here we need a payload, and you can simply pass your payload as an argument then. So in this case, an object with a value of 10, because we expect a payload in our store, which will be an object which has a value property. So that's why we pass an object with a value property here, simply as an argument to this automatically created method. And with that, we can change this button caption maybe to 11 to tell it apart from the other button, also change the value. And with that, now we got this new button, which also works. So now we're also mapping actions, and this saves us the time to add those methods on our own. There also is an alternative way of mapping actions. In case you're not happy with the default names, you can also call map actions and not pass an array to it, but an object instead. And then you can define the method names you want to have in your component as keys, for example, inc, and then hold the action which should be mapped to this method as a value. So with that, we could go with inc and increase like this. And with that, the increment action would be mapped to an inc method, increase would be mapped to an increase method. And therefore, we would have to call increment by calling inc now. Increase stays increase because that's how I'm mapping it. And with that, of course, that would still work if we try this. So map actions and map getters can be very, very useful. Now let's say our application is growing, and besides this awesome counter feature, we now also got a user auth component which deals with user authentication. So in there, we have a button where we say log in, and a button where we say log out, and it depends on the off state which button we're going to show. Now, of course, we could manage this locally in the component, but again, authentication might matter to a lot of parts of this app, so we want to manage it with vuex instead. Here, I just got this template with the two buttons. In app view, I'm now going to import user auth from components, user auth.view, and register this as a new component, user auth. And therefore, we can now use this, and I will create a new container here to also show it visually that this is a different part of the app. User auth. Give this container a title prop of auth, and make sure I only show the first container if we are authenticated. Now, at the moment, we see those buttons, but of course, they don't do anything. Well, that's something we can fix with vuex. And before I dive into the utility features we have for managing bigger applications with different kinds of state, here's a quick pause which you can use to add the functionality in vuex to react to a login and a logout click, to manage some is logged in state, to show just one of the two buttons, and to show or hide this base container based on the auth state. So add a new state and all the getters, mutations, and actions you might need to manage this is logged in state, which can be true or false in the end. Here's a chance for you to pause the video, thereafter we'll implement it together. Were you successful? Let's do it together now. So I want to manage an auth state. So in my state, in my store here, I will have a is logged in state. Of course, the name is up to you, which initially is false, let's say. Now, in order to change it, I want one or two mutations, depending on how you design the mutation. I will add one mutation and name it setAuth, where I expect to get the state, of course, and a payload. And the payload will be important here because it will tell me whether I want to set the auth state to authenticated or to not authenticated. So here I set state is logged in equal to payload is auth, let's say. And that can be true or false. Now, this is just my approach. You probably have a different one, and that might be fine as well. It's just one way of doing it. Now, that's my mutation, but we shouldn't necessarily call mutations directly from inside components, as you learned. So I will add actions. Now, we could add a setAuth action, which basically works like the mutation, or we add two actions to mix things up, a login action and a logout action. Again, it's just my way of implementing this. We get this context object, and in login, I want to commit setAuth. That's the name of my mutation, this one. And the payload will be an object here where I set isAuth to true, because it's the login action. I want to set the user to logged in. So this isAuth property, which I'm reading here in the mutation, is true now. And in logout, it's almost the same. It's the same mutation which I commit, but it's false. Now, of course, these actions could be asynchronous. In reality, we are probably sending some HTTP requests around, but here I will not care about that. I will keep it simple and keep it synchronous. But in actions, of course, we could also use asynchronous code, as you learned. So now we got actions, mutations, and a state. What's missing? A getter. So I will add a new getter. Name is up to you. I will name it user is authenticated. And in here, we get our state. And I will return state is logged in, which is true or false. Now I have everything in the store which I want to have there. With that, back in user auth, I want to wire up these buttons. So I'll add my script part and now add my methods for the actions that should be dispatched. We could use map actions here, or we add them manually, totally up to you. To show all approaches, I will add them manually here, add a login and a logout method here. And in login, I will call this store dispatch login, because login was the action name I defined. And for logout, it's the same, but of course with the logout action. And now we can set up the click listeners, trigger our login method on the first button, and trigger logout on the second button. With that, we should be manipulating the state. Now to reflect it, I also want to listen to changes. For example, here I only want to show one of the two buttons at the same time. For that, we can use computed to get access to the getters, either with map getters or by setting up our own computed properties. And here I'll add the isOff computed property, where I return this store getters, and I named the getter user is authenticated, so that's the getter I want to access here. And now isOff is a computed property, which is true or false. And with vif, I'll show the login button if isOff is false, because if the user is not authenticated, I want to show the login button. And I want to show the logout button if we are authenticated. And we can copy the computed property into the app view file now, here, like this, because I also need isOff here to show or hide this first base container. So here with vif, I want to show it if isOff is true and hide it if it's false. With that, initially we don't see it because initially we're not logged in. But if I click login, we see it, we can change everything. But if I click logout, we hide it. So that works, and that's an extra piece of state managed. Now that was a nice practice, but I started this lecture mentioning that our app could be getting bigger and that we had more and more state to manage. So here in this demo, we now added at least a little bit of extra info to our store. Vuex also gives us utility methods and features when it comes to managing bigger stores with different kinds of state inside of it. A pretty nice feature provided by Vuex, as your store and your state and so on grows, is the possibility to set up modules, to split your store into multiple modules. You may only have one store per application, but this store can be made up of multiple modules to keep your code more manageable. You automatically, if you don't set up any modules, have one module, you could say, the root module, the root state, but you can then add as many other modules as you want. For example, one module for the counter and another module for authentication. Or you leave authentication in the root state, in the root module, and outsource the counter into an extra module. That would also be possible. And that's what we're going to do here. So here in main.js still, I'm going to create a new counter module, which is an object. Not a store, just a regular JavaScript object. But now it's an object with exactly the same features as the object you passed to create store. So it may have a state method, it may have mutations, which is an object, it may have actions, which is an object, and getters. So exactly the same features. And in state, we of course also return an object. But now we can move our counter state here out of this global store into this counter module. The same for the mutations related to our counter. Grab them and move them here into mutations. The same for the actions, of course. Grab the counter-related actions, remove them from our global store, and add them to actions here. And you guessed it, the same for our getters. grab the counter getters, remove them from the global store, and add them to getters here. With that, our global store, our main store, is way leaner. It now has only the auth logic left, and we could put this logic into a separate module as well if we wanted to. But how do we now get the module back into the store? Well, create store, this object here, also takes a modules option. And modules is an object. And here, you now add all the modules you want to merge together into one store. You give every module an identifier of your choice, for example, counter, or numbers, or whatever the name should be. This is up to you. Here I'll go with numbers. And then point at the module object that should be merged. In this case, the counter module. Like this. And now this will be merged into this store. If you save this now, everything will work as before, because by default, modules merged into a store are all merged on the same level, so to say. So if you merge a module into this store, it is as if you would have defined all the getters and so on directly in the store, as we had it before a couple of minutes ago. That's why we can still dispatch all the actions and use all the getters as before, even though we're now using a module. And as mentioned, you can of course have as many modules as you want to. But the idea of modules doesn't end here. There's more we can do with that. I mentioned that modules are merged into your main store on the same level as all the other things in the store. You can change this behavior, and there is one place where it actually already did change. Let's say inside of a mutation, inside of the increase mutation, let's say, we console log our state. So that's inside of the counter module now, inside of the increase mutation. Well, let's have a look what happens if we click add 10. This is the log here for our state. And if we have a look at this, we see something interesting. Do you notice it? We see the counter in there, but there's one thing we don't see in here. Our authentication state. We don't see is logged in there, this state. Now I just said it would all be merged into one store. So why don't we see is logged in here in the state of our counter module then? Because the state inside of a module is actually treated as a local state inside of the module. Mutations, actions, and getters are global. You can access them as before on the main store. But the state is local to this module. So anything you do on this state inside of this module refers just to this state module. So for example, in a getter, I would not be able to get the auth status. If I add a new getter in the counter module getters object, test auth, and I try to return state is logged in, this will not work. If I now try to access test auth, let's say in the user auth component, we had another computed property is test auth, where I return this newly added getter test auth, which I just added to the counter module. If I access this here, and I then simply output the value, let's say in a paragraph, like this. So if I output this newly added computed property, which uses the new getter here, this will not work. First of all, though, I have to fix an error. In main.js, in the new test auth getter, of course, I should accept state as an argument in order to use it. But even with that, you notice there's nothing below the button. And if we change it, there's still nothing, because it doesn't find is logged in in the getter here, in the state of this getter, because this getter is in the counter module, and as I mentioned, the state is local. So here we only have access to the state that belongs to this module. So that's important to keep in mind. And it's similar for actions and mutations. There, in context, for example, where you learned earlier that you also have access to the state, in case you needed it, you also only have access to the state of this module. Now, in case you need to work around that, there are ways though. For example, in getters, inside of a module, you now don't just get state and getters as before, but you can now also get access to a root state and root getters. And you might remember that we saw similar properties on this context object earlier in the module. This is your way of getting access to the main state, the main getters of the entire store, instead of just the state of this specific module. So this is your fallback way of getting access to state that's not part of this module, in case you need it. Typically though, of course, inside of a module, you tend to just work with the state that belongs to the module. So you probably don't need this too often, but there can definitely be situations where you do need it. Now, besides this local state, you can also make the entire module local. You can make it namespaced, as it's called, to make sure that multiple modules are clearly separated from each other. Now, why might you want to do that? Well, as your application grows, you could of course have name clashes. You might be using the same getter or the same action name in different modules of the same store. It's not the case here, but if, for whatever reason, we had a login action here in the counter module, that would be clashing with the login action we got in our main store. Because at the moment, besides the state, everything is merged together into one object, basically. So in bigger apps, you could have such clashes, and to avoid that, you can namespace modules. You do that by adding an extra option inside of your object here, and that's the namespaced option, which you can set to true. If you add namespaced true, you tell vuex that now the entire module, and not just the state, should be kind of detached from the rest of the store. If you do that though, you will now notice that our getters and our action dispatchers no longer work. Because now these actions and getters are no longer available on the main store. Instead, now we have to access them by specifying the correct namespace. And how does that work, and what is the namespace? Well, the namespace is this key you assigned for adding the module in this module's object to your store. So in my case, numbers. That's the namespace of the counter module. And we now need to use this namespace to work with actions, getters, and so on inside of this module. Now here's how that will work. In favorite value, I access my normalized counter getter. Now you don't access .normalized counter, but instead a special property name, which contains a special character, and which you hence have to access with the square bracket notation. You pass in a string here, your property name as a string, and this property name is now made up of the old property name, so normalized counter, but prior to that, in front of that, you have your namespace. So in my case, numbers. So you have numbers and then a slash in between. Might look strange, but this is now the property name of the normalized counter. Namespace, slash, and then your getter name, action name, whatever it is. In this case, it's a getter. And that's why we now see at least one counter here. It's this normalized counter, which I'm outputting like this. Now, if you are using map getters, you pass a first argument to map getters, which is your namespace, in this case numbers, and then thereafter you still add your array with the getter names as before. So with that, if we save this, the second counter is back as well. So namespace as a first argument, second argument is then still your array of getters inside of that namespace. And the same, of course, for the other parts. Map actions takes the namespace as a first argument, and then your action names as before. And in app view, here where I dispatch manually actually, the type is now numbers/increase. So again, namespace slash and then the action name. With that, all the buttons work again now, and now we're using this namespacing feature to detach our module and to make sure that we don't have any name clashes, which we of course don't have here, but which you in bigger apps definitely could have. And with that, we're merging a module with our main store. We still have some global state in there, the authentication state, but we can absolutely combine it like this, and we're even namespacing our module to make sure that we don't accidentally trigger an action inside of this module when we actually wanted to trigger a global action, for example. With that, we are almost done with the basics, but there is one maybe obvious problem. The main.js file is huge. It has the entire store and even an extra module in there. And it might work for this app, but even here it's a lot of code. In bigger apps, I definitely don't want to have that all in main.js. Instead, just as with routing, you typically create extra files for that. You could start with a store.js file and outsource your entire store into that. That might be a good start. So let's grab the module and this store, cut it all from main.js, and instead add it in store.js. And then also, of course, cut the create store import, go to store.js, and add the import here, because we use create store in this file, and then in the end export the store as a default so that we can import it in main.js. Import store from store.js, and with that everything should be working again. Yes. But this is just a start. Store.js is still huge, and in bigger apps with many modules, this quickly becomes a super large file. Therefore, typically we go even further than that. Often you add a separate folder named store, and in there you then have your index.js file, which holds your main store creation logic. Then you have separate files for actions and mutations, possibly also for getters if you want to. And then we create separate subfolders for all the modules we might have, like the counter module. And in there, again, you could have an index.js file, actions.js, and so on to merge things together. Now I'm going to split it like this to show you how this could work. I will also be honest, for this demo, of course, that's all overkill. But with that, we have a bunch of files. And now let's see how we split the code into those files. In store.js here, I will grab from my main store this whole logic to create a store, including the export. And I will cut that and add it to index.js in store. So not index inside of counter, but index inside of store. Also grab the import here of create store and add that to index.js in the store folder. Now I grab my mutations, in this case the one root mutation I have here, grab this object here, and in the mutations.js file, I will simply export this object now. Again, this is overkill. Just having one object in a file, there would be nothing wrong with having that in index.js. I just show you the ultimate solution for very big apps here. So with that, I'm exporting my mutation object, and we import that in index.js then. Import mutations from mutations.js. Maybe also name this root mutations to make it clear that these are the mutations that influence our root state here. And I assign root mutations to mutations then. Same for actions. Grab the actions object actually, go to the actions.js file in the store folder, export it as a default, like this, and back in index.js, we then import the root actions from actions.js, and then assign root actions here to actions. And the same if you want for getters. Grab the getters, export them in the getters.js file, like that. And back in index.js, I import my root getters from /getters.js and assign root getters to getters. And now this is a very lean file. The state stays in here, by the way. Now for the modules. In store.js, I still have the counter module. I now grab this code so that store.js is empty, and hence we can delete the file, of course, and go to the counter folder in the store folder, and there in index.js I paste it in. And I export this entire object as a default, simply like this. I leave namespace here, I leave state here, but I grab the mutations object and move that to the mutations.js folder in this counter subfolder, and export that in here. And then again in index.js, but now in index.js inside of the counter, I import counter mutations from /mutations.js and assign those here to mutations. Same thing for actions. Grab the object, go to actions.js, export them here as a default, like this, and in index.js, import them. Import counter actions from actions.js and assign them here to actions. And last but not least, we can do the same thing here for getters. Grab the getters object, add a getters.js file inside of the counter, export our getters object like this, and then import it. Of course, you can tweak the file names, by the way. You don't have to use these exact file names. I'm just following some convention here, but you could also use a different file name here. So here I then have the counter getters from getters.js. So assign them here. And now this is all split up. I'm exporting my module here. So now in index.js here in the store folder, I can import my counter module from counter index.js and now assign my counter module to numbers. And now in main.js, we no longer import store from store.js, but from the store folder and there the index.js file. And with all that out of the way, it works as before, but now with a different folder structure. Now, if you want that structure or not is up to you, but it is one option. You can also change this a bit more. If you had multiple modules, you could also add a modules folder here and move counter into modules, and then have other modules like a products module folder, if you had some, in the modules folder as well, to make it clearer that you manage your modules in here. You then just need to adjust the import and import counter module from modules counter index. And as I mentioned before, you can also tweak the file names so that they make sense to you. You could also split actions, getters, mutations, and so on for the root state, but not for the modules. It's up to you which structure you want. I'm just showing you one possible approach to make sure that you have small, maintainable files instead of one super big file where you then have to search for things all the time. And therefore, this here is one possible way of building this. It is overkill for this demo, but of course it shows you what you can do in bigger apps. So now that we learned the basics about vuex, I want you to practice it in at least a little bit of a bigger application. You find this application attached. As always, npm install and npm run serve are your friends. And we got this very simple demo online shop there. Got 3 products, we can add them to a cart, and you see this cart counter increases every time I add a product. We can then view our cart, see the cart total here, see our items here, and we can remove items from the cart and everything updates. We also got this login button, which doesn't do anything at the moment actually, even though it should. But here we're facing some limitations by provide and inject. If you update something which is not an array or not an object, like in this case where I'm in the end updating is logged in, which is a boolean, changes to that will not be reflected back to the components that inject that status. We don't have to worry too much about this though, because your goal is a different one anyways. I want you to try to migrate this entire state, which is managed application-wide, to vuex. So the products and the is logged in state, also the cart. Set up vuex in whichever way you want, using modules or not using modules, using namespaces or not using them, and try this on your own as a practice. From the next lecture on, we'll migrate this together so that you see my possible solution. This will be a great practice and hopefully helps you understand how you really use vuex in projects. So, did you succeed? Let's try this together. For this, I will add a store folder here, and in there add an index.js file. I will also already add a modules folder because I will definitely use some modules. Looking at our state here in app view, I think we have 3 main kinds of state. We have the products, we have the cart. We could also treat products and cart as one state, the shop state, so to say. And we then have is logged in, which is the authentication state. Now there will be different ways of solving this, but I will put is logged in into my root state, so to say, so not into a module, but then I'll work with a products and with a cart module. And therefore in modules we can create 2 subfolders, products and cart, and there is nothing wrong with it, but I will use a different approach. I'll instead add a cart.js and a products.js file. That is not what I showed you in the last lectures. I am aware of this, but that's also an alternative. I don't want to split my mutations and so on in separate files here. Instead, I want to have them in one file, but still separate files for different modules. So that's an alternative to having multiple module folders where in every module folder you then have separate actions and mutations files, which you could also do though, just to make this clear. But with all of that, I'm going to npm install vuex so that we have this available here in this project and bring up the development server thereafter. And in index.js, in the store folder, I will then import create store from vuex. And then call create store here to create a store, which I then export as a default. This store takes an object, and we're going to configure the store here soon. Since I'm exporting the store, we can already import it in main.js though. Here, import store from store.js. And besides using the router, we will now also use the store. But now back to the store. I mentioned that I want to have some global state, the authentication status, and then module state for my different modules, for products and for the cart. Let's maybe start with products. For that, we're exporting an object in here, which will be our module object, and set up state, which is a method. It returns an object, which defines our state, and in here, I want to have my products array, which currently is in app view. So we can grab this entire array from app view, cut it, and go to products.js and add it here. Products is now this array. In app view, we therefore no longer provide products. And we remove products from the data property. Now for products, I actually have no mutations and actions because we never change products in this example app. Therefore, of course, this is not really state which we need to manage. It's just some static data, which we also could export and import like this. But to practice vuex, I'll put it into some state, even though that is state which will never change. There is at least one thing which we need though, and that's a getter. Because we shouldn't directly access state, we should use getters for that. So here I'll add a getter, also named products maybe, which gets the local state of this module, and where I then simply return state products, like this. So it's not a super fancy getter, it's not doing a lot of things, but hey, it's better than nothing. That's it for the products module already. So in index.js, where I create the main store, I can import my products module from modules products.js. And then add the modules key here and add, let's say, prods as a namespace if we want to use namespaces later. Otherwise, this is just required technically, but has no effect. And register products module under the namespace. Now, currently it is not namespaced. Currently it will be merged globally, so the getter will be available just like that. But I want to make it namespaced so that we also practice this. Therefore, we can add namespaced as an option in the exported module object and set this to true. And now prods will be the namespace for this module. Let's continue with the cart. Here in the cart, I of course want to have my cart data, so we can cut this from app view, but also later the methods that change the cart. So in cart.js, in the store modules folder, we export our module object, add our state, and here I return an object which has this cart. And actually, since this is an entire module for just the cart, we can also flatten this and just add items, total, and quantity as separate keys in this overall module state. Now here we will need mutations as well, because in app view I have two methods for changing the cart: add product to cart and remove product from cart. So I can grab these methods, cut them from app view, and add them to cart.js here in mutations. But we of course have to tweak those mutations now, because now they don't just get an argument and do something, instead they now need two arguments: the current state, which they should change, and a payload. The payload can then hold all the extra data that might be needed. Here, for example, I expect to get some product data describing the product that should be added to the cart. So to make sure that the rest of the code works, I will add a constant named product data, because that's what's getting used down there, and expect to get that on my payload. Let's say payload.product. We have to provide this payload later, so we can of course expect any data we want. We just have to make sure that this data exists later. And then we have to update the state. So here, for example, it's not this cart items find something, it's state items, because items is now a property in our local state of this module. Here it's also state.items.quantity. Assuming that items in the cart do have a quantity field. And they do because this is how we add items to a cart. We set up product ID, title, image, price, and quantity for that product in the cart. And this should all continue to work because this doesn't use the state or anything like that. But then here in the end, we access state items and push our new item. And we access state.quantity and state.total. So the other state properties which we added here. And that's the add product to cart mutation. Now for remove product from cart, we also get a state and a payload. And again, prod ID was received previously as an argument, so I will add a constant prod ID and extract this product ID, let's say, from the payload object. And then again, we search state.items here. And here it's also state.items, and we manipulate state items, state quantity, and state total. Now we got the mutations in place. Now we learned that we shouldn't directly commit mutations from inside components, so I'm going to add some actions as well. And here I'll add a add to cart action and a remove from cart action. And add to cart receives this context and maybe also a payload. And the same here for remove from cart. And in here I then simply commit add product to cart and forward the payload to the mutation. And for the other action, we commit remove product from cart. So that would be context commit remove product from cart and forward the payload. And with that, we just have to add some getters now. Getters that allow us to get access to various pieces of information about the cart. And here we can get creative. Previously, we shared the overall cart, and then in different components, we extracted different features. For example, in the user cart page, I extracted the cart total like this. In the header, I'm extracting the cart quantity here. Now we can define some getters for that in our module. We can have a cart items getter, which gives us the overall cart items, a cart total getter, which gives us the total sum, and a cart quantity getter. Or, since this is all in the cart module already, just name this items or products or whatever you want, total sum maybe, and quantity. And then here return state, which we get in a getter automatically, state items. Here in total sum, return state total. And here return state quantity. And now we can go to index.js in the store folder, import the cart module from /modules cart.js, and add this to our modules here as well. And I'm going to namespace this cart and save the cart module in there. Now with that we're not done, but we made an important first step. Now let's continue with cleaning up and with using the store in the next lectures. So let's continue now. For one, I get an error that store.js wasn't found in main.js. Yes, because I'm importing from store index.js. That would be correct. So make sure you have this import set up correctly. But besides that, we now also need to wire up our store with the different components and clean up the app view component. In there, I don't want to provide anything anymore because I don't want to manage any data in there anymore. We still have isLoggedIn in there, but we're going to remove this soon as well, just as these methods. For the moment, let's ignore them though. But let's now start using our modules. Now, one thing I forgot is in cart.js, in this cart module, I also want to namespace this. So set namespace to true in here. And now let's use it in the different parts of this app. For that, we can start in products list. Here, I previously injected products. We're no longer going to do that. Instead, I now want to get access to vuex. So we can add a computed property and either use the map getters helper or add our own computed property, which is what I will do. Maybe name it products and return this store. And now let's see. In the products module, I have the products getter, but keep in mind that this module is namespaced and the namespace is prods. So what we should access here in products list.view in the pages folder is .getters, and then it's prods/products. And this gives us a products computed property now, which we can use to loop for all the products. Now we currently can't preview this because we still got errors on the page, but this should work. Now let's fix the other errors. Let's make sure we also get the cart data in the header correctly. It's no longer cart quantity, but let's say cart quantity as this, like this, as a computed property in the future with this name. And we no longer inject anything here, but instead we add computed, add this cart quantity computed property, which I just referred to in the template. And in there, return this store. And now here, we also namespaced cart. So we access this store getters, and then use the cart namespace, which is cart, in the index.js file in the store folder. So access cart slash, and then the getter I'm interested in my case, is the quantity here. So that's slash quantity. Let's save that. And if you now reload, you should see products again and at least see cart. You can't go to cart or you'll not see anything there and the app breaks, but at least the first pieces are working now. So let's now work on the other parts. In user cart, I'm interested in the cart items. So here I'll change this and expect cart items, which I soon will add as a computed property. And I also use the cart total here. We no longer inject the cart here. Instead, the computed property for cart total will now refer to this store getters and then cart slash, what was it? It was total sum. So refer to total sum here. And add another computed property called cart items, or whatever you are using here in the v-for loop. And here return this store getters cart slash, and then it was products, I think. Yes, products was the getter name. With that, if we go to cart, this also works again. Now let's make sure we can also add things to the cart and remove them. So for that, we need to dispatch actions. So for the actions in the components folder, products, product item, I got the button to add something to a cart. Previously, I injected add product to cart for that. Now we can delete this and instead call this store dispatch and then dispatch a function which is named add product to cart. No, sorry, that's the mutation, which is named add to cart. That's the action. So dispatch this, but it's namespaced, so it's cart slash add to cart. And now, of course, this object here is the payload, which I want to transmit. And actually here we have to be careful. In the module, the vuex module, we forward that payload to the mutation. And in the add product to cart mutation, I expect to get a product key on my payload, which then has all the fields I try to extract. Now, if I just pass the entire object like this as a payload, there is no product key in there. So we either nest this data here into another object under the key product in this payload object, or we pass the payload like this and adjust our logic in the mutation to simply set payload as we get it equal to product data, from which we then extract ID and so on. And that's what I'm going to do because it means less code changes. Now in a card item, components card item, we got the logic for removing an item. Previously I injected this, no longer needed, so let's get rid of it. And instead here, I want to simply call this store dispatch card slash, and then the action name is remove from card. And on the payload, which we want in the mutation, I expect to get a product ID field in the object which I get. So in card item, I dispatch card slash remove from card and pass an object as a payload, which has a product ID field which points at this prod ID, which is this prop which holds the product ID. With that, theoretically, hopefully, we should be able to add and remove items. And you see the badge here updates as I add items to the cart. If I go to the cart, the total looks good. We see the cart items, and if I remove them, the total and this badge updates. So that seems to work. Now I get a warning regarding is logged in, but we'll fix this soon. The main thing here is that we now migrated the products and the cart functionality. Now to score some bonus points here, we could actually also change our add to cart logic. In product item, I'm currently passing the entire product data. We could argue that all the product data is already in our store, right here in products.js. Here we got all the products. So the only thing which we really have to pass here to add to cart should be the ID of the product. So let's do that. Let's get rid of the image and title and price here. Let's delete it and just forward the ID on the ID field. And now in the cart, in add product to cart, I get my payload which no longer holds all the product data. Instead, now here I just get my prod ID by accessing the ID field on the payload. That's all I get here. And this is of course not enough. Now the problem is, because everything is namespaced and the state inside of a module is local anyways, the state we're getting here is just this state. It has no information about the products. Therefore, we should actually get this product ID in the action, in the add to cart action, because in here, in this context, we actually also do get access to other parts of the vuex store, not just to this module. Here on context, we will have our root state object, which has access to the root state. But even more important than that, we got access to root getters. And on the root getters, we can get access to other namespaced getters as well. Namely here, to my products getter in the products module. How? Simply by accessing square brackets, then the namespace name, which in this case is prods for the products, and then the getter name, which is products here in the products module. With that, we actually get our products, and now we can filter out the product with this ID. So now we can get our product by searching products with the find method for the product where the prod ID is equal to the prod ID we got here. This is a built-in method for searching all items in an array, and when this function returns true, we got the item we want to have, and it then returns this item. And then it's this product which we can pass as a second argument, as a payload, to our commit method here. So now we receive the entire product in this mutation, and payload therefore again is the entire product data. If we now save this, hopefully adding to cart still works, and this does look good, and we still see our data here. But now we are getting it differently, a bit leaner, leveraging actions and not passing all the data around as a payload, at least not when we dispatch it inside of our component. It's up to you which approach you prefer, but this is a common scenario, therefore I also wanted to show this to you here. With that, the only thing that's left is the login state. Now let's finish this up by migrating is logged in. Currently we're managing it in app view, and that's of course not the goal. Instead, I'll manage this as a root state, which is not in a module, but which is managed in the store itself, though of course you could put it into a module if you wanted to. But with that, we return an object here, and in there we got is logged in, which initially is false in our main store. With that in app view, we can entirely get rid of data. Now I got these two methods, which I will now also cut, and hence we can remove methods here, and add them as mutations instead. So here we got the mutations, and in login, we get the state, and we change state is logged in and set it to true. In logout, we do the opposite. Now we also need actions, as you learned. So here I will also add login and log out actions. And we get our context here. And then context commit login here. And in logout, we do the same with the logout mutation. And then we can add a getter. Is authenticated, could be the getter name. The name is up to you, of course. Here we also get our state, and then we return state is logged in, which is true or false. And now we can wire up the rest of the app. In app view, we're not using authentication, but in the header, we are. Here I got login and logout buttons, and I'm using the is logged in state to show or hide an extra menu item. So to make that all work, I'll add methods here to wire up those buttons and add a login method, which will trigger this store, dispatch, and then log in. We got no namespace here because this is a root action directly in the store. Now, same thing for logout. Of course, with a different action being dispatched. And in computed, I will add a is logged in computed property, which points at the this store is authenticated getter we just added. So that is this getter. It's a global getter, not namespaced, which is why we access it like this. This here should be at click, of course, not at logout. This was a mistake on my side. It was fixed in your attachment already though, but make sure you have click listeners on those buttons. And then this works. The admin page doesn't allow us to do much, but we can go there. Now we stay there if we log out, but it's not about that at the moment. Instead, this is about vuex, and you now hopefully have a good understanding of how it works and how you may add it to your projects. So that's it for this module. You learned what vuex is, why you might want to use it, and how it works. It's all about having that central state which you manipulate through actions and mutations, and which you get through getters. You learned how to set all of that up, and how to manage more complex states with multiple modules and different folder structures. You also learned about the map getters and map actions helpers. Now, vuex in a nutshell isn't too complex. Yes, you need to write some extra code to manage state, but thereafter you have a clearly defined flow, a clear structure for managing state. And as you can absolutely see in this demo and the demo before, sharing state and manipulating it from anywhere in your app in a clearly defined way is super easy with vuex in the end. And that's why vuex can be very helpful in bigger projects and why it can make managing state a breeze. It's much nicer than provide and inject, at least in my opinion, in bigger projects, and can therefore definitely help you write any application of any size you want.